Hello, today we're working on a Haas VF3. This is a 1999 machine. It's in really good shape. The problem we're having with the machine is currently giving us an alarm of 153. And the alarm 153 is basically a broken wires or encoder contamination. It turns the servos off and says it can be caused by loose encoder connections. So we'd had this alarm in the past about 6 months ago, and this is on this is for the A-axis, the auxiliary axis, and that was on the T5C, which is that unit, and then it also is married up to a tilt rotary table. And the tilt rotary table is driven by its own servo control mounted up here on top of the machine. That all seems to be working fine. The problem we have here is with the T5C indexing, which is also directly tied in to the A-axis in the machine side. So it does have the fourth axis on it. In the past, we've had this alarm about 6 months ago, and coolant had entered up and through the top of the plug. The Haas uses these rubber washers, and they had dried out, and I don't know if they had been, exactly what had happened, but one of them was loose, and coolant, these are through-hole tapped holes. Coolant had gotten down in through there, and then over a period of time had filled up into the motor cover, and it got into the encoder, and we had put a scope on it, and the Z channel, the home channel for the encoder was not working. So we replaced the encoder, and everything was fine and good to go for about 6 months. Apparently, we've gotten the same alarm at this particular time, and the alarm only occurs when the fourth axis is in a certain position. So as it was doing that, we had reached up in here and had started messing around with this connection right in here where it goes right into the plug, and sure enough, you could make and break the alarm just by moving this cable. This cable goes in, and then this is encapsulated in epoxy resin. So if we had came back in here and tried to cut this out, we would have had a really difficult time trying to go through the encapsulation epoxy and all that, and it would have made up pretty much a boogered up repair. So we opted out to buy a new cable. The new cable as of this date was $289. And when you buy the cable, this is what you get. You get an instruction sheet here, of course the new cable, and we did verify that this part number here is what we exactly have on our machine. They said they had changed and put a new part number. Haas had given us a new part number. However, when we got the cable in, it still had the old part number on it. And then they also send you a new gasket, some more of those new rubber seals and O-rings for the connectors, the socket head cap screws that go through there. Looks like they've given us a bottle of RTV and a little pigtail. So what we're going to do today is we're basically just going to change this cable out, and this cable runs from here back down through the back side up to the top of the machine. I'll walk you around and show you where it goes. Sorry for the shaky movement. I did not bring a tripod today. It comes in through the top of the machine, back around to the bottom, into right here, into this Amphenol plug. And there you can see it's labeled as the A-axis. But I did want to make note of this. This is the original part number, 364025B. And that is the 17 pin. That is the same part number that we received with the new one. When we ordered it from Haas, they gave us a new part number of 93-4038. Of course, if you're watching this video, you're probably trying to do your own repairs, and you've bought enough parts for machine tools that you know they're constantly changing part numbers. It gets really, really confusing sometimes. But that's where we're at right now. We're going to basically dig all this old RTV out of here, and we're going to replace that cable. I'll bring you back around when we get the top of it disconnected, tie wraps cut loose from where it's going up through there, and it's loosened up onto the top. It's pretty simple install from that point. But we'll tear this out, and then we'll look at the plug. Okay, we've got the cable disconnected from the other end. Got the tie wraps cut off. Got it cleaned up. Got some of the metal chips out of it. We're going to remove this cover now. And this plug is encapsulated in epoxy. There's no really good way of getting it apart. And this would have been a really bad place. It's a high usage of this, moving around a lot, and this strain relief, and it just wouldn't have been a really good place to make a splice repair at. So we opted for a new one. So that's pretty much what it looks like on the back side there. Hope this will give you guys some kind of, if you're going through this and you've never done this, and at least it'll give you some sort of an indication of what you're up against. The new kit, the new cable came with a new gasket. So we're going to remove this gasket here and clean all this surface up. We'll start installing the new one with the new gasket, RTV, and all that, and go from there. Thought I'd take this apart, the old one, and show you what it looks like underneath the cap. There's 3 socket head cap screws here. That'll show you, this is the encapsulation, the epoxy. It's poured around the connectors, which are in turn in there. It's really non-serviceable. I mean, it's friggin' stuck in there. It's in there. So that's the inside of it there. Our problem lies right in here where the strain was on it. And like I said, this thing's been on here since 1999. This is 2016, so it's been there 17 years. So it's about played out. It's been on the machine since it was new. Been on the machine since it was new, and it's just time for a new one. So we're parts changing on this repair. I anticipate the next video may be able to take a do some IMA work as far as rebuilding drives and some scraping jobs and some other more intensive jobs. It's kind of hard to do that because normally when I'm at a customer's, it's pretty noisy in there, and I'm getting to work on a weekend and it's quiet and I'm in here by myself, so I thought it might be a good time to shoot a little simple video for a simple repair. And this is something that anyone can do, so maybe it'll give you guys an idea of what what you're looking at and give you a little bit more familiarization going into it. I'm over here trying to scrape off. We've got my putty knife and my Scotch-Brite, my putty knife, and I'm trying to get this old gasket and paint material off. I've got the gasket material removed, a little bit of elbow grease, got it all cleaned up. I am gonna seal these holes up. These holes are through holes. They're drilled all the way through and tapped instead of being blind. So I am going to put some RTV in these threads when I get ready to put the bolts in there. Try to get as much sealing done as this in here as we possibly can, because of course you guys know this thing is flooded with coolant. So, and then we'll get it all zip tied and tie wrapped back up, and we'll try it out. Okay, this gasket they sent with this has got the 3M glue adhesive on there, and that stuff is awesome. I mean, of course it's 3M, but when you go to place that, you've got to make doggone sure that you've got it lined up. I mean, once it sticks, it's stuck. I wanted to bring you around and show you this. This is the paperwork that came with the new cable, and this thing is basically says that this new cable will replace the following cables, and there's quite a few part numbers here. 10 different part numbers that this cable replaces, and they basically give you an IPB, an illustrated parts breakdown of how the screws and the O-rings and the washers and the plugs go and all that, but it's pretty self-explanatory. I guess this thing is this auxiliary cable. After looking through this auxiliary cable is this thing's made for brushless motors and brush type motors. What we have here is a brush type motor. Like I said, this was a 1999 model, so it's a little older, but yeah, it does have the brush, and they give you some more breakdowns and illustrated part breakdowns for different to check. They give you a procedure here to how to check, make sure you've got your motor rotation correct and things of that nature, but it's not really going to affect us here on our install, so we should be okay. We've got a DC motor on there, and should be labeled, should be correct. So I've checked it. We'll check and go through the procedures to make sure, but I don't anticipate a problem there. But we'll get this thing on the machine. Okay, here I've already got the cap back on. I did put RTV. I opted to use the RTV that I had, that Permatex high temperature red stuff. I've got it. I went ahead and used it instead of opening up another container. Plus I carry this open with me all the time. So we got it all sealed up real good. I've got the zip ties, got it zip tied back up to the air line, going back up to that strain relief up on top. And then, of course, it loops back down and goes right into the back of the Amphenol plug into the side of the cabinet. So this is going to pretty much wrap this one up. We'll fire this thing up and try it out. I'm going to let the RTV dry real good before we start throwing the coolant to it, and we'll see how it goes. But I suspect this is going to be a good repair. This is a real simple one. I wish they were all this easy. But anyway, I wanted to bring it along and try to make a video on it, so could maybe possibly help out someone else down the road. Thank you for watching, and we'll see you on the next one.